Okay, today I want to talk about the review for derivatives, integers, and improper integers. Today evening at 7 p.m., I want to review the limit, the L'Hopital's rule, and the relative rate of growth and sequence problems. Okay, now we can focus on the derivatives, the integers, and improper integers. You need to memorize these differentiation formulas. The constant prime is the 0. The x prime is 1. The x to the n prime is n times x to the n minus 1. The c times the function f prime is the take out c times prime. F plus minus g prime is f prime plus minus g prime. F times g prime is f prime g plus f times g prime, like product rule. F of g prime is quotient rule, top one prime times bottom one minus top one times bottom one prime over bottom one squared. The sine prime, cosine. Cosine prime, negative sine. The tangent prime, secant square. The cotangent prime, negative cosecant square. The secant prime, the secant times tan. The cosecant prime is negative cosecant cotangent. So we have a chain rule. The f of g of x prime is the f prime of g of x times inner function g prime of x. The power rule combined with the chain rule, the g of x to the power n prime is n times g of x to the n minus 1 times g prime of x. So we have more differentiation formulas. So do you remember what's ln of x prime? Could you write your answer on the chatting board, please? What is ln of x prime? Yep. Okay, good. The 1 of x. The ln of g of x prime is g prime of x of g of x by using chain rule. The g of x is inner function. The log x with base a prime is, do you remember? Could you write your answer on the chatting board? Do you know that? What is the answer? X prime is 1, you're right. And x prime is 1 over x times ln of a, because you can use base change. The log x with the base a is exactly same to ln of x over ln of a prime. So only take out ln of a. What does it mean? So this case is like ln of a is constant, only take out ln of a, 1 over ln of a times ln of x prime. So we have 1 over ln of a times 1 over x. That's it. This is the whole idea for solving this problem. Like this. The if x prime is itself, e to the g of x prime is, you can use chain rule, the e to the g of x times g prime of x. A to the x prime is a to the x times ln of a. The a to the g of x prime is a to the g of x times ln of a times inner function prime g prime of x. Inverse sine of x prime is 1 over square root of 1 minus x squared. Inverse cosine of x prime is minus 1 over square root of 1 minus x squared. Inverse tangent of x prime is 1 over 1 plus x squared. Inverse cotangent of x prime is minus 1 over 1 plus x squared. Inverse secant x prime is 1 over x times square root of x squared minus 1. Inverse cosecant x prime is minus 1 over x times square root of x squared minus 1. So how can you find derivative of the inverse function? We use this theorem. If the function f is 1-to-1 differentiable function with the inverse function is here, this one, and f prime of inverse of f of a is not equal to 0, we have this result. The inverse function is differentiable at a. The inverse of f prime of a is 1 over f prime of inverse of f at a. So I'm going to give the one example. The f of x equals the 3x plus cosine of 2x. Find inverse of f prime of 1. How can you do that? First, you need to check function f is 1 to 1. F prime of x is the 3 minus 2 cosine 2x, like this. So what happens? The sine of 2x is between minus 1 and 1. Between the minus 1 and 1. So what happens? 3 minus 2 times 1 is like maximum is 1. Minus 1. The minimum value is minus 1. Minus 1 times minus 2 times 3 is like 5. It's always positive number. So what does it mean? Function f is increasing. The increasing function is always 1 to 1. Because the function f is increasing function, you can draw horizontal line. We have only one intersection point. This is always 1 to 1 by using horizontal line test. You can use the theorem. Inverse f of prime of 1 is 1 over f prime of inverse f of 1. So you can follow this step. First, step 1. So you need to find inside 1 inverse f of 1. You can find inverse f of 1. This is step 1. You can find this one. Step 2. You can calculate denominator f prime of inverse of f of 1. Step 3, you need to use fraction. Exactly 1 over f prime of inverse of f of 1. It's like a whole idea. The step 1, inverse f of 1, we don't know. We can write unknown x. This is equivalent to use the definition of the inverse function. Inverse f of 1 equals x. Same to what? 1 equals f of x. So this f of x is this original function, 3x plus cosine 2x. 1 equals the 3x plus cosine 2x. So like this. You need to find x. So what is x? So could you run your answer on the chatting board? So which number has 1 equals 3x plus cosine 2x? Answer is the 0. Okay. So you can just check. You can plug 0 into x. We have 1 equals 3 times 0 plus cosine of 2 times 0. So this is the same to equivalent to 1 equals 3 times 0 is like 0. Cosine of 0 is 1. Yes, x equal to 0. You plug 0 into here. So what happens? We have inverse f of 1 is exactly 0. This is step 1. Step 2, you plug 0 into inside 1 inverse f of 1. Exactly f prime of 1. We already have f prime of x here. Only plug 1 into, this is like a 0, 0. This is like a 0 into here, 0 into here. We have 3 minus 2 times sine of 2 times 0. Exactly 3 minus 2 times sine of 0. So what is sine of 0? Could you run your answer on the chatting board? What is sine of 0? Yep, sine of 0 is exactly, yes, 0. Answer 3. So last step is you plug 3 into whole denominator. So we have 1 over 3. So that's it. This is final answer for solving this problem. So like this. The next tip, find differentiate. The f of x is ln of cosine square of 3x. So what's like the best way? First tip, do you know this one? ln of some function to the power n. This n is down, n times ln of x. So power 2 is cosine. This is like going down. Same to 2 times ln of cosine of 3x, like this. So you can find f prime of x. F prime of x is exactly 2 times ln of cosine 2x. The prime. This cosine 2x is like inner function. We can use this rule. ln of g of x prime is the g prime of x over g of x. You can use chain rule. You have to keep coefficient 2. The cosine 2x is log of g of x, exactly cosine 2x prime over cosine 2x. 2 times cosine prime is times inner function 2x prime over cosine of 2x. The 2x prime is just 2. You can combine. 2 times minus 1 is negative 4. We have negative 4 sine 2x over cosine of 2x. So this is the answer. One more. Do you know identity of cosine of sine of cosine? What is identity? Could you run your answer on the chatting board? What's it like identity of sine over cosine? Do you know that? What is sine over cosine? Okay. How about some other students? So you have the same answer, is right? What's it like identity of sine or cosine? Answer is yeah. Thank you. We have tangent of 2x. Yep. So we have it. This is idea. The next one, g of x is given. How can you find g prime of x? The g of x is 1 over arc sine. Arc sine of e to the 3x. The prime. We have 2 possibilities. You can use quotient rule or the power rule. I want to use quotient rule. 탑은 1 prime times arc sine of e to the 3x minus 1 times bottom function arc sine e to the 3x prime over bottom squared arc sine e to the 3x squared. As like 1 prime, here 1 prime is just 0. The 1 prime is just 0. This whole thing is gone. Was it like arc sine 3x prime like this one? You can keep minus 1. So we have this is keep negative 1 times arc sine prime is, do you know arc sine prime? Do you know this one? Look in the right. Was it like arc sine prime? The arc sine x prime is 1 over square root of 1 minus x squared. Only plug e to the 3x into x. So we have 1 over the square root of 1 minus e to the 3x squared times inner function e to the 3x prime over arc sine of e to the 3x squared. Like this. Also, e to the 3x prime is same to what? Itself e to the 3x times inner function 3x prime. 3x prime is 3. You can keep negative 1 times 3 times e to 3x is, you can keep negative 3 times e to the 3x is numerator over, like the denominator, the square root of 1 minus the e to the 3x squared The 3x times 2 is 6x, e to the 6x. Times the another denominator, the reciprocal of this one is arc sine with the 3x squared. We have arc sine of e to the 3x whole squared. That's it. This is the idea for solving these problems. Like this. The next one, the logarithmic differentiations. What's that? The logarithmic differentiation is used for finding derivatives of complicated functions involving products, quotients, or powers. Or the f of x equals g of x to the power hx. The one example is this one. Exactly, complicated function, product, quotient, and powers. That's right, exactly. These kind of things, you can use it. The same thing. Quotient, this is a power 1/2, power, right? Power and quotient form, you can use logarithmic differentiation. Another one, the g of x is ln of x. The h of x is power is a function 1 of x. The base is a function, power is a function. You can use logarithmic differentiations. What's that? Step 1, take natural logarithms of both sides of an equation y equals f of x and use the laws of logarithms to simplify. Step 2, differentiate implicitly with respect to x. Step 3, solve the resulting equation for y prime equal to f prime of x. Here, the last example, how can solve step 1? You can follow step 1. Step 1, y equals ln of x to the 1 of x is given. What's it like step 1? Step 1 is take ln the both sides. Take ln the both sides. So what happens? This one. So this is same too. The 1 of x is down. So ln of x, ln of x, ln of x. So like this. Step 2. You just only have step 1, ln of y equals 1 over x times ln of x. So step 2 is take derivative to both sides. Here, take derivative to both sides. Take derivative to both sides. So what happens? So this one is, ln of y prime is, you can use chain rule. The y is function. So we have y prime over y equals, this one is like a product rule, 1 over x prime times ln of x plus 1 over x times ln of x prime. So what's like a 1 over x prime, you can calculate. 1 over x prime is, you can use quotient rule, 1 prime times x minus 1 times x prime over x squared. The 1 prime is 0. X prime is 1, negative 1 over x squared. So we have y prime over y is negative 1 over x squared times ln of x plus 1 over x times ln of x prime. What is ln of x prime? You can use chain rule again. This ln of x is like inner function, ln of x prime over ln of x. The ln of x prime is 1 over x over ln of x. You have to simplify. Numerator 1 over x times the reciprocal of denominator. So we have 1 over x times ln of x. Here this one is 1 over x times ln of x. What happens? We have ln of x keep negative over x square plus 1 over the x times x is x square ln of x. This is like y prime of y. It's like step 2. Step 3. The third step is we already have y prime over y equals negative ln of x over x square plus 1 over x squared times ln of x. So we have this one from step 2. Was it like step 3? Step 3 is multiply the both sides by y because we have to solve this equation for y prime. So this is like this. So what happens? Cross out y. The final answer is y prime is, what's y? You can replace ln of x to the 1 of x. Times remaining things, the minus ln of x over x squared plus 1 over x squared times ln of x. So that's it. This is the whole idea for solving this problem. So like this. The next one. So we think about the most important integrals. The integral k dx is kx plus c. Integral x to the n dx is 1 over n plus 1 x to the n plus 1 plus c. Integral 1 of x dx is ln of absolute value of x plus c. Integral g prime of x over g of x dx is ln of absolute value of g of x plus c. Integral e to the x dx is itself e to the x plus c. Integral e to the kx dx, could you write your answer on the chatting board? What is integral e to the kx dx? Do you know that? Could you write your answer? K times e to the x is right? So what do you think? K times e to the kx is right? So really be careful. So e to the kx prime is e to the kx times kx prime. So we have k times e to the kx. So integral e to the kx dx is 1 over k e to the kx plus c. Really be careful, this kind of things. E to the ax dx is the a to the x over ln of a. Similar. The a to the x prime is the a to the x times ln of a. A to the x, take integral is a to the x over ln of a. Sin x dx, negative cosine. Integral cosine x dx, positive sine. Similar. Do you know this one? Was integral cosine kx dx? Do you know that? What is your answer? You can change it. So replace x by kx. So could you run your answer on the chatting board? So what is your answer? Integral cosine kx dx is, do you know answer? The similar, we have sine kx over k plus c. So really be careful. The k times sine kx is derivative. The negative sign something. The sine kx over k plus c. Integral secant square is tangent. integral cosecant square is negative cotangent. Integral secant tangent secant. Integral cosecant cotangent negative cosecant. Integral tangent is ln of absolute value of secant x. Integral cotangent x is ln of sin x plus c, but you don't need. You don't need to memorize this one. You don't need it. Integral secant x dx is the ln of absolute value of secant x plus tan x plus c. Integral cosecant x is ln of cosecant x minus cotangent x. So same. You don't need this rule. Integral 1 over square root of a square minus x square. The inverse sign of x of a plus c. Integral 1 over a square plus x square dx is 1 over a inverse tangent of x of a plus c. The strategy for integration, what's that? Type 1. The integral f of x times g of x dx is given. The f of x times g of x is a product of a polynomial and a transcendental function, or two transcendental function. You can use integration by parts. So do you know transcendental function? The transcendental function is like logarithm function ln of x or something like that, or e to the x, the trig functions, or like inverse trig functions. These kind of things we call transcendental function. You can use integration by parts. Integral u times dv is u times v minus integral v times du. The question, how do you choose u from the integrand of an integral? Use a principle of precedence for u. The LIAT, we can use this order. L is logarithmic function. I is inverse trigonometric function. A is algebraic function. I can replace it. This polynomial is good. You can change it. Polynomial is what? Just algebraic function. This is algebraic function. The including the square root of x, x to the 1/3 or something like that. So t is the trigonometric function. The e is exponential functions. The remark, we can interchange ln I. Type 2. Integral sine to the power mx cosine power nx dx. The case 1, the power m from the sine function is odd power 2k plus 1. Step 1, save one sine factor. Step 2, use substitution. U equals cosine, du equals negative sine x dx. The multiply both sides by -1. The negative du equals sine x dx. Step 3, use identity. Sine square of x is 1 minus cosine square of x. Next, you can plug u into here. So we have 1 minus u square and find antiderivative. Case 2, the n equals 2k plus 1. The power of cosine is odd. What's step 1? Save 1 cosine. Step 2, use substitution. U equals sine. du is cosine. The step 3, use identity. Cosine square of x is the 1 minus the sine square. You plug the u into sine 1 minus u square. Case 3, m equals 2k, n equals 2p, the all even powers. You can use half angle formulas. Sine square of x equals 1 over 2, 1 minus cosine 2x. Cosine square of x is 1 over 2, 1 plus cosine 2x. Step 2, you can use integral cosine kx dx. Exactly same. 1 over k sine kx plus c. The one example is integral sine square over power 4x dx. How can you solve this problem? You can use half angle formula. We can plug 4x into, here you can plug 4x into x. You can plug 4x into x. What happens? 이내가 1 over 2 times 1 minus cosine of here. The 2 times 4x is 8x. So you have to keep 1 over 2, find n-positivity. 이내가 1 is just x. Minus 이내가 cosine 8x is the 1 over 8 sine 8x. Plus c, you can distribute 1 over 2, 1 over 2x minus 1 over 2 times 1 over 8 is 1 over 16. Sine of 16x, sorry, 8x, sorry about that. Sine of 8x plus c. This is your final answer by using the case 3, like this. So type 2, 이내가 tangent to the power m, secant to the power n dx. Case 1, the power m is 2k plus 1, like odd power. Step 1, save 1 secant tangent. Step 2, use substitution. U equals secant, du is secant tangent dx. Step 3, use identity. Tangent square of x is secant square of x minus 1. You can plug this u into here. U square minus 1. Case 2, the power n is even power. The power n, like from the secant function, is even power. Step 1, save 1 secant square of x factor. Step 2, use u substitution. U equals tangent. du is tangent prime secant square of x dx. The step 3, use identity. Secant square of x is 1 plus tangent square. You can plug this u into here, 1 plus u squared. Case 3, other cases, the guidelines are not as clear cut. We don't have a clear cut, so just the problem by problem. Case by case. Type 3, the integral f of x dx where f of x contains the following expression, like this, right? So we have the a squared minus x squared form. What is x? X is a sine theta. A squared plus x squared form, you can use a tangent theta. X squared minus a squared form, x is a secant theta. The next, you have to eliminate square root form by using identity. The 1 minus sine square root theta is cosine square root theta from here. The 1 plus tangent square is secant square. Secant square minus 1 is tangent square. You have to simplify. The next, you can use the triangle. Was it like case 1? Here, divided by a. We have sine theta is x of a. You can draw right triangle. So what's that? X over a is sine theta. How can you find adjacent? By using Pythagorean theorem. Hypotenuse square minus side squared. So here, second one, divided by a, the both sides. Tangent theta is x over a. So what's that? The opposite over adjacent. How can you find the hypotenuse? You can use Pythagorean theorem. The last one, here, divided by a. So we have secant theta is x over a. What's x over a? Hypotenuse over adjacent, x over a. So by using the Pythagorean theorem, you can find opposite, the square root of x squared minus a squared. It's like a whole idea. Type 4, integral nx over dx is polynomial over polynomial form. How can you solve? The depending on power. So bottom power is greater than top power. Only use partial fractions. Second case, top power is the greater than or equal to bottom power. You have to use long division. So you have to reduce power on the top. Next, use partial fractions. Step 2, you can use useful integrals. integral 1 over x dx is ln of absolute value of x. Integral g prime of x of g of x is ln of absolute value of g of x. Integral 1 over a squared plus x squared dx is 1 over a inverse tangent of x of a plus c. Integral x to n dx is 1 over n plus 1 x to the n plus 1 plus c. Sometimes double angle formula is very useful. The sine 2x is 2 sine x cosine x. Cosine 2x is cosine square minus sine square, same to 2 cosine square of x minus 1, same to 1 minus 2 sine square of x. Type 5, integral f of x dx, where f of x contains the nth root of ax plus b or nth root of g of x. The first, try to use the substitution rule. U equals inner function ax plus b and g of x, the next one, but failed. So what happens? You can use another u substitution. This whole thing is u. This whole thing is u. This is the idea. Summary. How to evaluate the integrals? We have 5 methods. You can use integration formulas, substitution rule, integration by parts, the trigonometric substitution, and partial fractions. We have 5 methods are possible for solving integral problems. We are going to problem. So the problem is like this. The which method is possible? The which one? The which one is possible? What do you think? The what kind of method do you want to use for solving this problem? Integral x over 9 plus x to the 4. Could you write your answer on the chatting board? The integration formulas, the u substitution, the integration by parts, the like a trigonometric substitution or partial fractions. You can use u substitution. Okay. What's u? So what is u? The u is the could you write u? What is u? You said you use u substitution. What is u? So what is u? The here was it like a best way? Not x. So we have x is the top, minus x to 4. What's the best way? So like this one. We can find 9 plus x squared. Yes, x squared. This one, you can use substitution. U is x squared. The du is x squared prime dx. We have du equals 2x dx. Divided by 2. 1 over 2 du equals x dx. So let me see. This is same to what? Integral. The u equal to x squared is like a new function g of x. You can plug lower limit, upper limit into here. Exactly g of 0 and g of root 3. So what's the bottom one? X squared is here. You can plug the 9 plus u squared. Here, x dx is, we have 1 over 2 du. du, the 1 over 2 du. You can take a 1 over 2 integral. Plug 0 into here. 0 squared is 0. You can plug root 3 into here. The root 3 squared is 3. The 1 over the 9 is 3 squared plus u squared du. What's like antiderivative? The 1 over 2 times the, what is this one? Do you remember this one? 1 over a squared plus x squared dx is 1 over a inverse tangent of x of a plus c. So we have 3 is like A, 1 over 3. Inverse tangent of x over 3 from 0 to 3. So we have 1 over 6 plug 3, not 2. Inverse tangent of 3 over 3 minus 1 over 6 inverse tangent of 0 over 3. This same to 1 over 6 inverse tangent of 1. This one is inverse tangent of 1 minus 1 over 6 times inverse tangent of 0. No, u is x squared, but not x. The u is like x squared, not x. Yeah, u is x squared. Yeah, x squared is u. The u is x, the does not. So here, what does it mean? Inverse tangent is supposed to be u. Yeah, this is no, the x is not the u. This is like x squared is like u. Yeah. Oh, you mean here? Yeah, right. So in this case is here, we can compare. This log of x is exactly, log of u. You're right. Sorry. You're right. Thanks. My type. You're right. U over 3. You're right. Yeah, sorry. Thank you. Inverse tangent of u over 3. You're right. Yes. Plug 3 into u, 3 over 3, and 0 over 3. So next tip. Was it like inverse tangent of 1? The inverse tangent of 1 is, yep, this is pi over 4. We don't know angle theta. You can change it. 1 equals tangent theta. The tangent theta equals 1. Angle theta is exactly pi over 4. This is 1 over 6 times pi over 4 minus, what's the inverse tangent of 0? Do you know inverse tangent of 0? The inverse tangent of 0 is, do you know that? What's the inverse tangent of 0? We can use same idea. Angle theta, 0 equals tangent theta. Tangent theta equal to 0, what's angle theta? Angle theta is like 0. So we have 1 over 6 times 0. Answer is pi over, the 6 times 4 is 24. Yeah, this is like a final answer for solving this problem. The next one. How can you solve this problem? The first integral. Which method do you want to use? Integration by parts, the use substitution, the trigonometric substitution, partial fractions, what integration formulas. So which method is good for this problem? Also, use substitution, you're right. What do you? This one? Yep, ln of x, because ln of x prime is 1 over x. This is the reason. The ln of x, find du. Du is ln of x prime. dx. So du is, the ln of x prime is 1 over x dx. This is integral. Let me see. We can write this also g of x. The bottom one is g of e. Top one is g of e cubed. 1 over ln of x is u. One more. 1 over x dx is du. We have a simple form. Next, find antiderivative. What is integral 1 over u? I can change a little bit. The g of e, you can plug e into here. ln of e is 1. You can plug e cube into here. ln of e cube is only 3. Does it make sense? Or like a ge, you can plug ge is ln of e. Only cancelled 1. What is g of e cube? E cube is ln of e cube. ln e cancelled, only 3. We have changed it, 1, 3. Next one, yes. This is what? The 1 over u, the du. Find antiderivative ln of absolute value of u from 1, 3. You can plug 1, 3 into here. ln of absolute value of 3 minus ln of absolute value of 1. What is ln of 1? Do you know what is ln of 1? And then 1 is, yes, the 0. Final answer is ln of 3. This is the whole idea. The next one, here. The which method do you want to use? Integral x squared over x cubed. So what kind of method do you want to use? So this problem. Which method? The integration formulas, use substitution, integration by parts, the trigonometric substitution or partial fractions. Which method do you want to use? Yeah, also use substitution. What's u? U is, yep, x cubed, you're right. Find du. Du is x cubed prime. dx, the du is x cubed prime is 3x squared dx. Next, divided by 3. So we have 1/3 du equals x squared dx. So this is same to integral. So 1 over x cubed is u, e to the u. Next, x squared dx is the 1/3 du. We have 1/3 du. We can take out 1/3. The e to the 1 over e to the u is e to the negative u du. So what would you like to answer? We can use this rule. Integral e to the kx dx is e to the kx over k plus c. Would you like e to the integral minus u du? 1/3. The k is minus 1. The minus 1 exactly e to the minus u over minus 1 plus c. Exactly negative the 1/3 times e to the negative u plus c. I'm going to change this one to the positive exponent, 1 over e to the u. The last one, I'm going to change this one to the x variable. U is same to x cubed, change back. Minus 1 over 3 times e to the x cubed plus c. This is your final answer for solving this problem. This one. The next is integral 1 to e ln of x over x cubed dx. How can you solve this problem? Same, use substitution, the integration by parts, the trigonometric substitution, or partial fractions. So which method do you want to use? The use substitution is possible. Use substitution. So we cannot use substitution because some possibility of u is ln of x. U equals ln of x was du. Du is ln of x prime dx, 1 over x dx, but we have 1 over x cubed. It's not good. So another one, x cubed equal to u. Find du, 3x squared dx. My point is, how can you change ln of x? So we have some trouble. So what's like the best way this problem? You can use integration by parts. We can change this one to the integral 1 to e. We have 1 over x cubed times ln of x dx form. So we can use integration by parts. You can decide u. How can you decide u? You can use LIATE. Here, 1 over x cubed is algebraic function. Here, 1 over x cubed is algebraic function. The ln of x is logarithmic function. The here, what does it mean? This is u. So we have u equals ln of x. The dv is remaining part 1 over x cubed dx. Find du. The du is ln of x prime. ln of x prime is 1 over x. How can you find the v here? How can you find the v? The v is integral 1 over x cubed dx. And calculate the integral x to the negative 3 dx. Find antiderivative 1 over the negative 3 plus 1 x to the negative 3 plus 1 plus c. So we have 1 over negative 2 x to the negative 2 plus c, same to negative 1 over 2x squared plus c. So this is like integration by parts. You don't need to see. We have negative 1 over 2x squared, like this. So what's that? Exactly u times v. So we have negative 1 over 2x squared times ln of x from 1 to e minus integral the v times du. So we have negative 1 over 2x, sorry, this is ln of 1 over x dx, sorry, d equals 1 over x dx, minus 1 over 2x squared times 1 over x dx from 1 to e. So next, you plug e into x, negative 1 over 2 times e squared ln of e minus negative 1 over 2 times 1 squared ln of 1. Change positive, take a 1 over 2 plus 1 over 2 integral 1 over x cubed dx from 1 to e. You need to simplify this one. The ln of 1 is 0. What is it like ln of e? Could you write your answer on the chatting board? What is ln of e? Yes, ln of e is like 1. So we have negative 1 over 2 times e squared. You can keep plus 1 half. Integral 1 over x cubed is here. We have it. The negative 1 over 2x squared times negative 1 over 2x squared from 1 to e, and simplify. Negative 1 over 2 times e squared. So this one is keep e into here. The plus negative 1 over 2 times 2 is 4. 4 times e squared. Minus plug 1. Negative 1 over 2 times 2 is 4 times 1 squared. So what's that? It's the same to the negative 1 over 2, negative 1 over 4 e squared combined. What's that? This is negative 2 over 4 times e squared plus negative 1 over 4 times e squared. Change positive plus 1 over 4. This is 1 over 4 is positive. Combine these two things, negative 3 over 4 times e squared. So that's it. This is your final answer for solving this problem. Okay, so like this. The next one, integral x squared times sine 3x. You can use same. So x squared is algebraic function. Sine function is the trigonometric function, exactly the product of the algebraic function and the transcendental function, we use integration by parts. We use LIATE, the same. The x squared is algebraic function. Sine 3x is here. This one. So what's that? You can use this rule. Was it like u equals x squared? 답은 remaining part dv equals sine 3x dx. Find du. du is 2x dx because x squared prime dx. What's v? v is integral sign. What's integral sign? Integral sign is the negative cosine 3x over 3, the next one. So we have like a v. So this one is first one, u times v. So we have the negative x squared cosine 3x over 3 minus integral the v times du. v times du is the 2x times negative cosine 3x over 3 dx. Negative x squared cosine 3x over 3. Change positive, take out 2, take out 3. Exactly. Plus 2/3. integral x times cosine 3x dx. That's right. The next two. This one is minus x squared cosine 3x 3. You have to keep. You can keep coefficient 2/3. So how can you find integral x cosine 3x dx? You can use integration by parts again because LIATE again. X is algebraic function. Cosine 3x is the trigonometric function. What is u? u equals x. The dv is cosine 3x dx. Find du. X prime is 1 times dx. The v is integral cosine. Integral cosine is the sine 3x over 3. This is like a v. So what's that? You can use a bracket. First one, u times v. So we have x times sine 3x over 3 minus integral here. The v times du sine 3x over 3 dx. So this is same to here. Negative x squared cosine 3x over 3. Distribute 2/3. 2/3 times this one is the plus 2x sine 3x over 9. Take out 3 times 2/3 is 2 over 9. Keep negative 2 over 9. 2 over 9 integral sine 3x dx. So what's the answer? Negative x squared cosine 3x over 3 plus 2x sine 3x over 9 minus 2 over 9. You can find integral sine 3x. Integral sine 3x is negative cosine 3x over 3 plus c. You have to simplify. Negative x squared cosine 3x over 3 plus 2x sine 3x over 9. The minus 1 times minus 1 is positive 2 cosine 3x over 9 times 3 is 27 plus C. This is like a whole idea for solving this problem by using integration by parts twice. Okay, the next one. Here. So let me see. This is an integral of the product of two different trigonometric functions. How can you find integral? Do you have any idea? So could you write your idea on the chatting board? How can you solve this problem? Which method is possible? The use substitution, integration by parts, the trigonometric substitution, partial fractions, integration formulas. What do you think? Could you run your answer on the chatting board, please? So do you have any idea? So this problem, we are going back to my lecture, summary of integration. You can check it, power under sine, power under cosine. The power sign is like odd power. What's the best way? Step 1, you can save one sign. Change it, sine to the 4x. Keep cosine 2x. Save one sign. Step 2, you can use U substitution. You can save sine function, the U equals cosine of x. So du is cosine prime negative sine x dx. The multiply the both sides by -1, negative du equals sine x dx. This one. So what happens? Integral. Cosine x is exactly u. You have to change u square. Sine x dx is negative du. Just like a du. Take out minus sign. How can you read sine to the power 4? You can use identity. What is sine to the power 4? Same to sine square of x squared. So what is sine squared? Same to 1 minus cosine square of x. You can plug u into cosine 1 minus u squared. So we can plug this one into here. We have 1 minus u squared. You keep negative, you have to expand. So 1 minus u squared is 1 minus 2 times u squared plus u to the power 4 times u squared du. You can keep negative. You can distribute u squared to the first, second, third one. We have u squared negative 2 times u to the 4 plus u to the 6 du. So next, keep negative, find antiderivative. Integral u squared is 1/3 u cubed. This is 2 over 5 u to the 5 plus 1 over 7 u to the 7 plus c. So next, change back. 1/3. This u is same to cosine. The change back. Cosine cube x minus 2 over 5 cosine 5 plus 1 over 7 cosine to the power 7 plus c. That's it. This is your final answer for solving this problem. The next one, integral x squared over 4 minus 9x squared to the power 3 of 2 dx. So how can you solve? Do you have any idea for solving this problem? Could you write new idea on the chatting board, please? How can you solve integral x squared over 4 minus 9x squared to the power 3 of 2 dx. Do you have any idea? So we have, do you know that? Use substitution, the integration formulas, the trigonometric substitution, partial fractions, integration by parts. So which method do you want to use for solving this problem? So could you write your answer on the chatting board, please? So what do you think? So which method do you want to use? So could you write integration by parts? Is it right? Let me see. The integrand has these kind of forms. So we have, so the constant square minus function square. We have to use what? So a times sine theta. We have a square plus u square form. What's it like to u? U is a times tangent theta. You can just trigonometric substitution. Integrand has function square minus constant square form. U is a times secant theta. This is the whole idea. So what does it mean? You can change this one to the integral x squared over the 4 is 2 squared minus 9x squared is 3x squared to the power 3 of 2 dx. What does it mean? Similar to the constant scale minus function scale form. So what's it like u? U is 3x. So we have 3x is u is 2 times sine theta. 2 times sine theta. So like this. You can divide by 3. X is the 2 over 3 sine theta. Find dx. Dx is keep 2/3. The sine prime is cosine. So like this. So what's that? Integral. You can plug the 2 over 3 sine theta into this x. We have 2 over 3 sine theta. Square over. You plug the 2 sine theta into 3x. So 2 square is 4 minus the 2 sine theta squared. This is whole power 3 over 2 times dx is here. 2/3 cosine theta d theta. 2/3 cosine theta d theta. Is right? So what's like this one? The integral, the 2 over 3 square is 4 over 9. 4 over 9 sine square of theta. What's like bottom on? I'm going to simplify bottom on. What's the bottom on? 4 minus 2 sine theta square is same to what? 4 minus 4 sine square theta. Same to what? Factor for 1 minus sine square of theta. You can change 1 minus sine square is cosine square. The 4 times cosine square of theta. So what's like a power 3 over 2. You can take power. This is a whole power 3 over 2. Power 3 over 2. Power 3 over 2. So this is 4 to the 3 over 2. Cosine square of theta to the power 3 over 2. So what is the answer? 4 to the 3 over 2 is, I can calculate. The 4 to the 3 over 2 is, the 4 is 2 square to the 3 over 2. 2 is crossed out, 2 cube is 8. So we have only 8. So 2 is crossed out, cosine cube theta. So like this. So here 8 times cosine cube theta times 2/3 cosine theta d theta. So we have it. The next, only take out all coefficient. 4/9. So add like a denominator 1/8 times 2/3 이내거 top has sine square. What's the bottom one? The cosine theta is crossed out only 2. We have cosine square. D theta and simplify. For A2 is crossed out. We have 1/27. 이내거 I'm going to change cosine, sine of cosine. Do you know what is the sine of cosine? Do you know that? What is sine of cosine? Yeah, tangent square with theta, you're right. So we change it tangent square. So 1/27. So we don't have integration formula of integral tangent square. You can change the identity. Tangent square of theta is same to secant square of theta minus 1. So d theta, so we have it. So you can keep 1/27. The integral secant square is tangent theta minus integral 1 is only theta plus c. The next, change back theta to the x variable by using this relation. What is the relation? We have the 3x equals 2 sine theta divided by 2. 3x of 2 equals sine theta. You can draw right triangle. So what is sine theta? The opposite over hypotenuse. You can find adjacent by using Pythagorean theorem. 2 squared equals 4 minus 3x squared is 9x squared. We have it. So what's that? It's the same to 1/27. So what's like a tangent theta? Tangent theta is opposite over adjacent. So we have the 3x over the square root of 4 minus 9x squared minus what's angle theta. So from here, you can use inverse function. So here, theta is same to what? Inverse sine of 3x over 2. So this is the sine, inverse sine of 3x over 2 plus c. So that's it. This is whole idea for solving this problem by using the trigonometric substitution. This is like a main idea for solving this problem. It's good. So we are going to the next one. This is idea like this. The next, how can you solve? 이내거 the 4x cubed negative 4x minus 3 over 2x squared minus x minus 1. How can you solve this problem? This is exactly polynomial over polynomial. The polynomial over polynomial. You can use the long division and the partial fraction. So here, top one power is 3. The bottom power is 2. What does it mean? You have to use long division first. What's like a long division? Like this one. You can divide numerator. The 4x cubed. So we don't have x squared term. You can write 0 times x squared negative 4x minus 3. Numerator divided by denominator 2x squared minus x minus 1. How can you eliminate the 4x cubed? We need 2x. The 2x times 2x squared is 4x cubed. 2x times minus x is negative 2x. The 2x times minus 1 is negative 2x. Next, subtract. The 4x cubed is cancelled. The negative 2x is positive 2x. The negative 4x plus 2x is negative 2x squared. 2x squared. Sorry about that. This one. The minus 4x plus 2x is negative 2x. The minus 3 is like down, so like this. The next, how can I eliminate 2x squared? We need only 1. The 2x squared times 1 is 2x squared. The minus x times 1 is negative x. Minus 1 times 1 is negative 1. And subtract. The 2x squared is cancelled. The negative 2x minus x is changed, positive. The minus 2x plus x is negative x. The negative 3 plus 1 is negative 2. So we have it. You can change this one to this form. What's that? Integral. We have 2x squared. This is like a quotient, 2x plus 1. Plus the remainder, negative x, negative 2 over the 2x squared minus x minus 1 dx. You can change it like this. So next tip, you can use partial fraction for solving this part. We have negative x minus 2. You have to factor denominator. You factor denominator. How can you factor? This one is 2x and x. So we end the 1 and the minus 1. We need, which one is a minus 1? Here. This is a minus 1. This is like a plus 1. We have this kind of things. You just only change a over x minus 1 plus b over 2x plus 1. So you can combine this one. How can you combine? You can combine the a times 2x plus 1 plus b times x minus 1, the cross multiplication, b times x minus 1 over common denominator, x minus 1 times 2x plus 1. This is the same to distribute a, distribute b, and combine. 2ax, bx, you can do factor out x, the 2a plus bx. We have 2a plus bx. We have it. Remaining part is a times 1 is a. The b times minus 1 is negative b. Over common denominator, 2x plus 1 times x minus 1. The next, you have it, equation. The 2a plus b is exactly coefficient of x. 2a plus b is coefficient of x, exactly here, minus 1. The constant is a minus b. A minus b is the constant part, negative 2. The next, you add these two equations. What's that? Exactly. The 3a equals negative 3. You can divide by 3a is minus 1. You can plug minus 1 into here. So what happens? We have 2 times minus 1 plus b equals minus 1. You add 2 to the both sides. The 2 is cancelled. What's it like b? The b is positive 1. So what's that? So we can change it. This one to the integral the 2x plus 1. This form is exactly partial fractions. What is a? A is minus 1, b is 1. So we have this one, the plus negative 1 over x minus 1 plus b is 1 over 2x plus 1 dx. You can split integral 2x dx plus integral 1 dx minus integral 1 over x minus 1 dx plus the integral the 1 over 2x plus 1 dx. You can split. The next, find antiderivative. So what's that? The integral 2x dx is exactly x squared plus integral 1 is just x. Integral 1 over x minus 1. I'm going to use this rule. Do you know this one? Integral g prime of x over g of x. dx is the ln of absolute value of g of x plus c. So let me see. The x minus 1 is g of x. What is g prime? What is x minus 1 prime? Could you write your answer on the chatting board? The g of x is x minus 1. X minus 1 prime is, what's x minus 1 prime? Yeah, this is 1. So we have, this one is exactly g prime of x. So we have, keep this one, the minus, ln of absolute value of x minus 1, the like this one, the plus. What do you like the second one? Similar. You can use here. This is g of x. This is what? G of x. What's it? 2x plus 1 prime. 2x plus 1 prime is 2. But this is 1. How can you do that? You can change it. Times 2 divided by 2. This is idea. So far, 2x plus 1 is exactly g of x. The 2 times 1 is 2 is same to g prime of x. So what's the like answer? Answer is here 1 over 2 ln of absolute value of 2x plus 1 plus c. So that's it. This is your final answer. Okay. So how can you solve this problem? You have to use the long division and partial fractions. This is the whole idea for solving this problem. The long division and partial fractions. This is the whole idea for solving this problem. The next part, we think about improper integral of type 1. Case 1, integral a to infinity f of x dx. How can you solve? Only replace infinity by t and take limit. Limit t value approaches positive infinity, integral from a to t f of x dx. Case 2, integral negative infinity to b f of x dx. Same. You can replace minus infinity by t and take limit. The limit of t value approaches minus infinity, integral from t to b f of x dx. The improper integral is conversion. What does it mean? Limit value exists. What's like exist? So value is finite. It's a finite number conversion. Improper integral is divergent. The limit does not exist. What does it mean? Does not exist. The limit is infinity, minus infinity, sometimes oscillate. So like this, the improper integral is divergent. Case 3, the integral from minus infinity to infinity f of x dx. You can split two improper integrals, integral from minus infinity to a f of x dx plus integral a to infinity f of x dx. The improper integral is convergent. What's that? Both improper integral are convergent. Improper integral is divergent. The either one is divergent. The one example is first one divergent, second one convergent. What's the final answer? Divergent. The first one is convergent, second one divergent, answer is divergent. Is right? It's like whole idea. So the widely choice of A, the best choice is what? 0 is better. You can choose as what? 0. It's like one good choice. improper integral of type 2, case 1. The function is discontinuity at b. How can you calculate? The limit t-value approaches b from the left, integral from a to t f of x dx. How can you decide the left-hand side, the right-hand side of this one? How can you decide this one? So idea is not difficult here. This is a and b is given. You can choose t. So we have discontinuity at b. The t-value approaches b from the left, just like idea. The discontinuity at a, integral from a to b, f of x dx. How can you calculate? Limit t-value approaches a from the right, integral t to b, f of x dx. How can decide the one side limit? Same. A, b. Choose t between a and b. We have discontinuous at a, t-value approaches a from the right, like this. The improper integral is conversion. What's that? If the limit exists. The improper integral is divergent if the limit does not exist. The third case, discontinuous at c. The c is between a and b. How can you do that? Split two improper integral. Integral from a to c f of x dx plus integral c to b f of x dx. Integral from a to b f of x dx converges. What does it mean? Both improper integral are convergent. The improper integral is divergent if either one is divergent. It's like the whole concept of improper integral. The next, we can try to solve the two more examples together. The first one, integral 0 to infinity x over e to the x dx. How can you solve these problems? So let me see. Change what? The limit t-value approaches infinity. The t-value approaches infinity. Integral from 0 to replace infinity by t. So x over e to the x is the same to what? X times e to the minus x dx. Like this. So how can you calculate this integral? So could you write your answer on the chatting board, please? So what is your method? The u substitution, integration by parts, the trigonometric substitution, partial fractions. So which one do you want to do? Yes, the by parts is possible because x is a polynomial, e to the minus x is exponential function. You can use integration by parts. You can use LIATE, LIATE. X is algebraic function, e to the minus x is exponential function. So which one is like u? Top one is u. The u is x, the dv is e to the minus x dx. Find du. X prime is 1 times dx. The v is integral e to the minus x. What's integral e to the minus x? You know, e to the minus x dx is, do you know that? What's integral e to minus x dx? Could you write your answer on the chatting board? What's integral e to minus x dx? Yeah, so exactly negative e to the minus x plus c. So we have it. So we have negative e to the minus x. So this one is the limit. T value approaches infinity. What's the first one? U times v. We have the minus x times e to the minus x from 0 to t. Minus integral 0 to t, the v times du. The v times du is 1 times e to the minus x is negative e to the minus x dx. So we have it. So same to limit. The t value approaches infinity. What's that? I'm going to change this one to the positive exponent. The minus x is like the top. We have e to the x from 0 to t. -1 times -1 is change positive, equal 0 to t e to the minus x dx. This is same to limit t value approaches infinity. You can plug t into here, negative t over e to the t minus negative 0 over e to the 0. What's integral e to minus x? Negative e to the minus x from 0 to t. So what happens? 0 over e to the 0 is 0. It's gone. The limit t value approaches infinity. The first one is negative t over e to the t. Plug t here. So before plug t, I'm going to change it to the positive exponent, negative 1 over e to the x from 0 to t. What's that? Limit. The t value approaches infinity. First one is negative t over e to the t. You can plug t minus 1 over e to the t. Negative negative 1 over e to the 0. So t value approaches infinity, t and the e to the t. You can use relative rate of growth. The relative rate of growth which one is growing faster? T and e to the t. Which one is growing faster? The e to the t or t? Which one is growing faster? Yeah, bottom one is growing faster. Whole thing is going to 0. This one. Bottom one is going to infinity. 1 over infinity is 0. So answer is, so minus 1 times minus 1 is positive 1. The e to the 0 is 1. Just 1. So what does it mean? This is finite number. What's your final answer? The final answer is improper integral. 0 to infinity x over e to the x dx is conversion. The conversion to 1. This is the whole idea for solving this problem. Next, last example. Here, the last example is this one. How can you solve this problem? You can plug 5 into x, exactly 1 over 5 minus 5 to the power 4 is 1 over 0 undefined. Undefined, what does it mean? The function 1 over x minus 5 to the 4 is discontinuous. Discontinuous at 5. So you have to split 2 improper integral from 3 to 5. 1 over x minus 5 to the power 4 dx plus integral 5 to 7. 1 over x minus 5 to the power 4 dx. You can split. So first, the users only solve this one. How can you solve this one? Here. The integral 3 to 5, 1 over x minus 5 to the power 4 dx. So you can change the limit. You can replace the discontinuous point by t. 3, 1 over x minus 5 to the power 4 dx. Here, the t value approaches 5 from the left from the right. How can you know that? You can draw domain 3 to 5. T value is between 3 and 5. T approaches 5 from the left. We have left hand side. So like this. left-hand side. How can solve? You can use U substitution. U equals x minus 5. The du is x minus 5 prime is 1. 1 times dx is only dx. So you can change it. This one is g of x. What's that? Same to limit. T value approaches 5 from the left. 이내거 you can plug 3 into here, g of 3. Plug t into x again, g of t. 1 over the x minus 5 is u. U to the power 4. This one. This is the same to limit. T value approaches 5 from the left. 이내거. What is g of 3? You plug 3 into x. 3 minus 5 is negative 2. You plug 5 to t into here, t minus 5. This is u to the negative 4 du. You can find antiderivative. Limit. T value approaches 5 from the left. 이내걸 u to the minus 4 is power rule. 1 over negative 4 plus 1. U to the negative 4 plus 1. From negative 2 to t minus 5. So this is same to limit. T value approaches 5 from the left. So let me see. So what's that? So this is minus 1/3. U to the negative 3 is 1 over u cubed. So we have negative 1 over 3 times u cubed. From negative 2 to t minus 5. So you can plug t minus 5 into u. So minus 1 over 3 times t minus 5. T minus 5 cube. The plug minus 2, the negative minus 1 over 3 times negative 2 cube. So like this. You can plug 5 into here. What happens? Exactly minus 1 over 0 form. So in this case, we have two possible answers. Positive infinity, one negative infinity. Top one is negative. One more, you can use one side limit. The t value approaches 5 from the left. I can choose test number 4.9. You can plug 4.9 into t. The 4.9 minus 5 is minus 0.1. The minus 0.1 cube is negative number. The negative number times 3 is also negative number. Bottom is like a negative. So what does it mean? This one is going to positive infinity. Positive infinity minus a finite number is also positive infinity. What does it mean? Divergent. The final answer is, so this one is what? Divergent. So automatically, the original one is divergent. Do you remember the definition? The either one is divergent, the whole thing is divergent. So we have answer is integral from 3 to 7. 1 over x minus 5 to the power 4 dx is divergent. This is like the whole idea for solving this problem. Okay, so it's a very long time. So thank you for attending my class. I very appreciate. So if you have any trouble, any question, could you write your question on the chatting board. If you don't have any more question, you can leave live session. So I want to talk about the limit, L'Hopital's rule, and the relative rate of growth and sequence problem on today evening, the 7 p.m. Okay, thank you for attending my class. You're welcome. Okay. Arc cotangent negative square root of 3, you said? Oh, sure, I can just show to you. Yeah. So your question is here. arccotangent negative square root of 3 is right. Arccotangent negative square root of 3. Oh, it is from the homework. Okay, sure, no problem. I can just show to you. So here, arccotangent negative square root of 3. I can write here is better. Share whiteboard. Yep. So let me see. So your problem is this one is right. Arccotangent of negative square root of 3 is right. This one is right. Yeah, this is exactly we don't know theta. So you can change it. Minus root 3 is cotangent theta. The cotangent theta. So you can change. This is negative root 3 is what's the cotangent theta? Cotangent theta is exactly 1 over tangent theta. Only flip, the root 3 is the here. The negative 1 over root 3 is tangent theta. Was like a tangent theta is 1 over root 3, so you can use this idea. So we have tangent function. Tangent function is positive, negative, positive, negative. Exactly the second quadrant or first quadrant. The tangent theta, we can use reference angle, tangent theta prime. Tangent theta prime is exactly 1 over root 3. What's angle theta prime? Exactly pi over 6. We have pi over 6 here. Pi over 6, another one here, pi over 6. What's like angle? Exact angle is this one. This one is 5 pi over 6 is one thing. Angle theta is, what's that? 5 pi over 6. Or so from here to here, negative pi over 6. Do we have it? So what is the answer? The which one? So do you know which one? So you have to use the range of arccotangent. Remember, was it like range of arccotangent? The range. So the range is like this. I can see there here a little bit. So we have arccotangent. Yeah, 0 and pi. Yep. Here, do you know arccotangent of x is like a y value? Was it like the range? You can just see the textbook. The range is from 0 to pi. It's like a range of arccotangent. So arccotangent. So don't use this one. Answer is 5 pi over 6. This is the whole idea. It doesn't matter. You can use a cotangent theta equals minus root 3. You can use it directly, but we don't know some special angle. I want to use like one identity. Cotangent theta is 1 over tangent theta. You have to flip. Only flip tangent theta, just to flip, you have minus 1 over 3. Yeah, this is like idea for solving this kind of problems. Does it make sense? Is it right? So what do you think? So does it make sense? Okay, good. You're welcome.